and welcome to the InfoQ podcast. I'm Daniel Bryant, News Manager here at InfoQ and Product Architect at DataWire, and I recently had the pleasure of sitting down with Anurag Goel, founder and CEO of Render. Render markets itself as the next generation of cloud provider and aims to provide a platform-as-a-service-like experience for developers. In October of last year, the company won the Startup Battlefield competition at the TechCrunch Disrupt San Francisco event, and since then I've been seeing increasing buzz around this and other Kubernetes-based PaaS-like offerings. I was keen to ask Anurag how platforms like Render fit into the current landscape and how the adoption of the next generation of PaaS-like offerings will impact current operations work. I was also keen to explore the developer experience around Render and get Anurag's thoughts on what he believes the short to mid-term future of software engineering will be like. For example, will it be more containers, more functions as a service, or some kind of mix in between? Lastly, as the Render platform runs on top of Kubernetes, I was keen to understand what the team's experiences of managing large-scale clusters have been like. I also wanted to explore the challenges of running state-based applications and data stores on Kubernetes and understand how the team had made the platform and applications observable, both internally and for developers deploying onto the platform. Hello, Anurag, and welcome to the InfoQ podcast.
Thank you, Daniel. Thanks for having me.
Could you introduce yourself and provide a brief introduction to your work for the listeners, please?
Yeah, my name is Anurag Goel, and I'm the founder and CEO of a startup called Render. And we are a new cloud provider. We make it really easy for developers to install and deploy and run their applications online. And this includes everything from a really simple static site to a complex set of microservices. And we have features that a lot of cloud providers, including some of the bigger ones, do not yet have. And our goal is to try to continue to make it easier and easier to deploy applications and run them and scale them online.
So what do you think is your most typical use case you'd see on the platform?
I think it has to be a regular website or just a bunch of different websites that all comprise a single property, a web property, but also a single website might just be the front end. There is typically an API or a backend that it's talking to, which is also running on Render. Then we also have obviously background workers and cron jobs, which are running on Render. And then you can do sort of other things where you can deploy WordPress or Discourse or Mattermost on Render with a single click. So all of those things are possible, and we see people doing a variety of things.
Very nice, very nice. So how does this differ, say, from classic infrastructure as a service, IaaS, and PaaS? Obviously, kind of a spectrum there from SDKs and APIs controlling the actual VMs and so forth. To PaaS is very much a Git push type mentality. Where does Render fall on that spectrum?
So we're definitely much more on the Git push side of the spectrum when it comes to the ease of use. Having said that, we're much closer to the infrastructure as a service, what we think of infrastructure as a service today, the functionality that it gives you. We're closer to that on the functionality and the feature spectrum. So to give you an example, you cannot run a private service that is only accessible to other services in your account. So let's say you wanted to run an Elasticsearch cluster that is not visible to anyone outside your cluster of services. Now, Heroku, for example, doesn't even allow that. There's no way to run a private service on Heroku. And with AWS, you have to go set up a VPC. They have to set up security rules, IAM policies, all kinds of things to make that possible. Whereas on Render, all you do is tell us this is a private service. We automatically spin it up, give you a URL, an internal URL that is only accessible to other services in your account. And we take care of service discovery and all that. So you don't have to do anything. You just, again, have to just git push and tell us it's a private service.
Nice. I'm keen to break down a bunch of things there, actually. One phrase I've heard you say, I think at the TechCrunch video I watched, was you used the phrase legacy cloud. I thought that was a great phrase, yeah, because, cloud's only been around for 15 years or something. But is this kind of what you're meaning with legacy cloud? Like legacy cloud, I have to often be quite verbose in my configuration.
Yeah, it's not just the configuration, it's also the amount of work you have to do in terms of engineering costs. Any large company today that's running on one of the three big cloud providers, AWS, Azure, or Google, is almost inevitably building out an extremely large DevOps team. And most of the people on that team are simply keeping the servers up. They're not really doing really core technical, interesting work. All they're doing is sort of maintaining AWS scripts and dealing with CloudFormation and things like that, that just are very low level. So what I mean by legacy cloud is when the tech industry started moving from on-premise servers to the cloud and VMs, we didn't really change the paradigm that we were operating on. So we just took the servers in the data center and Amazon made them VMs in the cloud. So that's the only thing that changed. Virtualization was sort of the biggest advantage. And you know what? You can also use virtualization in the data center, and a lot of people do. So we are not really talking about a major shift in how applications are deployed and run in the cloud and what that means for the end user. So if you had a team of DevOps people running applications in the data center, they just switched to running them on VMs. And now, we see things like Kubernetes where now people have to figure out how to manage a Kubernetes cluster, how to install all kinds of Helm charts on it and upgrade things, and things break. And the CNCF landscape has, 1,000 things on its diagram, and it keeps growing, and it's too complex. We've taken a step back in terms of cloud usability. And I think we're seeing the effect of that, where people are coming out and saying, no, I don't want to use Kubernetes. I just want something to be really simple. And even within organizations, we're seeing a whole team or several teams dedicated to making Kubernetes easier to use for the developers in their companies. So our goal is to prevent everyone from having to repeat that work over and over and over again in every single organization. And so what we're doing is offering you all the functionality that you would get from Kubernetes without you having to configure that yourself, without you having to maintain a Kubernetes cluster or having a large DevOps team. So, just to give you a sense of the numbers, if you had maybe 20 engineers on your DevOps team on AWS, if you moved to Render, or the similar size company was running on Render from the start, you would probably only have 5 or less, because we take care of so much in terms of setting up your infra, scaling it, securing it. You just don't have to worry about it.
Interesting. Have you got any use cases there? Because I appreciate it's very easy to sometimes to say, isn't it, from 20 to 5 in terms of teams. Is there any kind of public use cases you could share at all?
Well, so I think the thing, perhaps it's worth talking about a big presidential campaign that's running on Render that was using GKE before they switched to Render. And they were tired of the complexity and the maintenance costs on GKE, which is, for your listeners, I think they all know what I'm talking about. And they just didn't want to deal with it. All they wanted to do was make sure they could run the website and keep it up and make sure that people were able to go to the website, read the candidates' policies, and donate. And we have since had them survive, and not just survive, but thrive on Render during multiple debates. And the next one, which is probably the final debate before the US primaries, is coming up on the 14th, I think. And we're all really excited now. And at this point, their DevOps team doesn't even exist. They were able to reduce all the engineering work that they would have had to do on GKE to practically nothing. And right now, the developers and DevOps people are able to focus more on things like, all right, well, what does my application need to perform better? And how do I most optimally scale my app? Now, those are the kinds of things that I think DevOps people want to do, but they're not able to because they end up doing all this thankless, undifferentiated heavy lifting just to keep things up. And they don't get rewarded for it because no one cares if things are working. DevOps and IT organizations are only spoken to when things are down. So it's a very thankless task. And we're also trying to sort of just take all of that out of the picture and make things easier for DevOps people and more interesting, honestly.
Yeah, it reminds me, I had some interesting chats in the previous podcast editions talking about site reliability engineering. You mentioned undifferentiated heavy lifting, which I like that phrase a lot. There's also this notion of reducing toil. As engineers, we don't like doing the same thing over and over again. We'd rather automate it, yeah? And I guess Render is very much aiming towards that side of the spectrum.
Yes. So it's all about automating as much as possible and giving you the tools to run really complicated services on top that you would otherwise either not even think of because it's so hard to do on AWS. And we've had users tell us, look, if Render didn't have really easy private services, I wouldn't even build this app because AWS would be too hard.
So when I look at Render, it looks to me like a PaaS-like offering, and these have been around for quite some time. Why is now the right time to introduce yet another offering like this into the market?
I think it's just timing and how we've matured as an industry and how deployment and just the layers of abstraction have changed in terms of sort of, thinking about servers versus thinking about VMs versus thinking about containers. And I think the biggest thing that has changed that allows render to exist now in a way that's much more user friendly versus other clouds and also offers more features is really the rise of containerization and the rise of things like Kubernetes. And we're able to utilize a lot of those ideas and a lot of the work that a lot of amazing people have done at these companies like Google and Amazon and Microsoft. But we're able to use all of that to provide our users a great experience and not just build technology for the sake of it.
So the render platform itself is run on top of Kubernetes, I believe. Do you use a hosted service or do you provision these clusters yourself?
So part of it is running on managed Kubernetes, but we realize that managed Kubernetes does not do what we would want to do to be able to render on it, because we run into bugs with managed Kubernetes where we adopted a new version and it just started failing. It just wouldn't start new pods. And this happened actually during our TechCrunch presentation. And so all these people were signing up for render, trying to spin up new services. And we were in the middle of sort of just like preparing and giving this presentation in the middle of all of that, and things just broke. And we spoke to our cloud provider, and first they told us it was our mistake and we had too many objects in our etcd store. And we were like, we're clearly not running the biggest Kubernetes cluster there is. And then they spent, I think, a week, and in the end they did admit that it was a bug in the Kubernetes version that they rolled out that had to do not with Kubernetes but their implementation of it. So we've decided that we actually need much more control over Kubernetes masters and over our own clusters. And so all our clusters from this point onwards are going to be just pure Kubernetes. As long as we're using Kubernetes, we might not always use Kubernetes. And I think that for us, Kubernetes is not something that we ever want to expose to our users. If we can think of better ways to give people the same functionality and ease of use, then we might use something else.
Very interesting. So how are you rolling out Kubernetes? Are you using CNCF type technology like COPS or kubeadmin, these kind of things? Or have you got your own tools that you've developed internally?
Right now, it's mostly our own tools, so we're not using COPS. We don't do a lot of rollout work on our clusters. Like once a cluster is there, we use the Kubernetes API quite a bit, and we end up using just your regular YAMLs, and then we use Terraform every now and then. But I think, again, we've realized that going forward, we're actually going to start using and are using kubeadm more and more. And I think that's going to be the tool of choice if and when we're setting up new clusters. But again, none of this actually matters to our users. It's much more important for them to get the functionality that they need and the reliability, the scalability, and security that they need. And Kubernetes, like I said earlier, is just a means to achieve those objectives.
Can I lift and shift my existing Kubernetes applications, config, YAML, Helm, all this kind of stuff directly onto render?
You can run all the apps that you would run on Kubernetes on render, but if you want to deploy a Kubernetes YAML, something that has an API version, a line at the top, that's not what we're doing. We're not building a managed Kubernetes host. And Kubernetes really is just a tool that helps you achieve business objectives. So our goal is to actually have infrastructure as code that is much higher level. So if you go to our website and search for YAML, we have our own YAML, but in that YAML, you don't specify things like, I want this service which should be a load balancer, or I want this ingress which should have this other thing, and I want to set up cert manager so I can issue SSL certs. You don't have to deal with any of that. All you tell us is, I want this service from this Git repo, and these are the environment variables I need. And in some ways, it's very similar or at the same level of abstraction as like a Docker Compose. So people can set it up really easily, but it can do very complex things. So we were able during the TechCrunch demo, and for your listeners who might not have this context, the TechCrunch demo that you and I are talking about is the one we gave when we participated in TechCrunch Disrupt, sort of a battlefield for startups. And we were the winner of TechCrunch Disrupt in SF this year. And it was a great pool of startups. And so we got really lucky. But the demo that we had there was essentially just a single click deploy of Mattermost, which includes 4 or 5 different backend services, including Elasticsearch and Redis, and 2 backend servers and 2 front-end servers. And we did that in HA mode with a single click, all using render.yaml. And the render YAML, the file was just a single file that was about maybe less than 100 lines.
That's pretty compelling, yeah. Because you mentioned things like Helm, and Helm tries to lift the abstraction up away from Kubernetes to some degree and define how apps are, say, packaged and deployed. For example, your configuration, does it specify how we build the application? Does it include, say, notions of things like build packs?
So we don't have build packs because we think that they are not the right abstraction level. I think that build packs, to me, are sort of fairly bloated because they try to be everything to everyone. And when you look at an actual build pack, you'll see all these conditionals in the code and all these variables that you have to configure. And when something goes wrong in a build pack, you don't actually know how to fix it. And then you have to open a pull request somewhere for them to update the build pack, or you have to fork it and change the build pack, and then you can understand what it's doing. So there are all these issues with build packs that basically made us think, okay, so what is it that I'm trying to do when I build an app? And really all we ask for in your either YAML file or even in the dashboard is a build command. Now, your build command runs in the context of an environment which has basically all the primitives that you would need to build your service, but you know best how to build your app. So we don't actually assume that you're going to build your app in a certain way. You just give us a script, or it could just be a single line that we run in the context of your application. We clone your code. We make sure all the libraries and the OS requirements exist, and then we run your build command and make sure that it works.
Very cool. So once I've built my app, I then maybe need to wire a couple of things together, maybe an Elasticsearch cluster like you mentioned, or maybe other services. And again, I specify all that in the render YAML, what talks to what, for example.
And render YAML also lets you connect services just like you can in, say, a Docker Compose. You can say, I want my service to get an environment variable from my Elasticsearch config. And so you don't even have to worry about sort of linking them yourself. You can just specify that in the YAML, and we automatically populate the right environment variables wherever you need them. And we also allow you to generate new environment variables in the YAML itself. So if you wanted to generate a secret, for example, you just say, generate this value for me, and then no one has to worry about that secret. It's not in your GitHub repo. And we automatically populate that as an environment variable that you can use elsewhere.
So how does service discovery work in Render?
So behind the scenes, service discovery is just based on DNS, and we're using the same primitives that Kubernetes uses for service discovery. So there's a DNS application, the DNS server running in our clusters, and it is responsible for responding to requests for a particular URL. So let's say you're running a private Redis server in Render that you don't want to expose on the internet. The URL you get is just going to be something like Redis:6379. And then your other applications can just use that URL to connect to it directly. And we make sure that all the network configuration is set up so that only your services can connect to it, and no one else even knows that those services exist.
Very nice. So I'm quite interested in the moment in the concept of a service mesh. And one advantage of service mesh is you can deal with sort of the non-functional or cross-functional requirements. So maybe doing retries, maybe doing kind of circuit breaking at the kind of network level. Is there any concept of that within Render?
Not right now. It is something that we've been keeping an eye on over the last few months. I think that the whole concept of service meshes is still evolving, and it makes much more sense for perhaps cases where you have a lot of different kinds of services that all need to talk to each other in a uniform way. The thing with Render, though, is that most of the services running on Render, or at least a large percentage of services running on Render, are new services that people are building because, it's harder to migrate an existing service from AWS if you have all those security groups and IAM and all of those things set up. It's a little bit harder to migrate it over to Render without downtime, especially if you have a large team of engineers. So I think Render is much better suited for new services that you're building. And when people are building these new services, they're actually sort of building them with the Render service discovery and parent, all of that in mind. So they don't even sort of need or think about service meshes. And when it comes to circuit breaking and retries, it's on our roadmap. And it's something that our users haven't asked for in a big way. They want us to build out object storage first, and they want us to build out a managed Redis service first, even though you can use existing object storage like S3, and even though you can use managed Redis on any cloud provider, we're seeing that people really want to keep everything in one place. And once they start using Render for one service, they end up wanting to bring all their services into Render, which is great. And that includes, they don't even want to log into the AWS console to deal with S3.
One thing that is very popular in the API gateway and service mesh space is the ability to do traffic splitting. So, for example, canary releasing or incrementally moving traffic from one version of the service to another version, these kind of things. Is this possible in Render? And if not, how do developers release their applications to end users?
So our users right now just get zero downtime deploys out of the box. And what that means is that they can actually define a health check on their application. And when they deploy a new version of their application, Render runs that health check and makes sure that the application is healthy. And even if they don't define a health check, we know which port your application is listening on. We detect it when you deploy an app, and we run a quick TCP check to make sure your application is responding, even if you haven't defined a health check. And so if our system discovers that the health check is failing or that your TCP check is failing, then we just simply mark that deploy failed and nothing changes as far as your users are concerned. And if the health check succeeds, then we start moving traffic over to the new app and make sure that we spin down your previous instances gracefully. So we send those instances a term signal and then sort of wait and then send them a kill signal.
Very nice. So changing perhaps gears a little bit, I'm kind of curious, how tricky is it to run data stores within, say, Kubernetes or behind the scenes? You mentioned about, say, a managed Redis and these kind of things. How difficult from an engineering perspective is it for your team to actually offer that as a service to customers?
Surprisingly, not as difficult as people would have you believe. And we've had our managed Postgres service out in the open for nearly a year. Now, we only launched in April last year, but we were in private beta for a while before that. And we have tons of people using managed Postgres without issues. And I think that it might have been harder maybe 2 years ago, where people were like, well, Kubernetes doesn't have the primitives. But it's also changed because people want to run things like Postgres in Kubernetes. And so guess what? The next release of Postgres probably has some features that make it easier to do that. And it's not just Postgres, it's also things like Citus or, for MySQL, you have Vitess, and all these people are creating Kubernetes focused deployment docs and things that allow their users to manage databases in Kubernetes. And it's the same thing for something like CockroachDB, which is just like Kubernetes as a first-class citizen for them. And they help you install it. And so I just don't think that the FUD around running stateful workloads in Kubernetes that is all it is. It's just FUD.
What do you think about observability and sort of understandability as well? I guess you're baking some of these things into the platform. Any sort of thoughts around how difficult that's been too?
It hasn't been. Again, things like Prometheus make it quite easy to do. And we're able to display usage and CPU and memory metrics to our users on the dashboard. It just comes out of the box. You don't have to install a third-party monitoring service. And all of that is very doable because we're able to use primitives like Prometheus in the backend. And I think this is where the timing aspect of Render makes much more sense. None of this stuff was available 5 years ago. When I started thinking about Render, the first time I thought about it, I waited for a year after that to actually start the company. And it was because I didn't think that it was possible for a new startup, and at the beginning it was just me, to build out a new cloud provider, given AWS is so entrenched into everything. But our users and our numbers say otherwise, so I'm glad that I decided to do it.
So you mentioned Prometheus there, which is a cloud native computing foundation CNCF hosted technology. As Render is building on top of Kubernetes, Prometheus, and other CNCF technologies, what is your opinion on the CNCF and the many components within the CNCF landscape?
I think there's going to be consolidation in that space. I just don't think that all the different startups and even large companies that are all attacking very specific niches in the Kubernetes ecosystem, I don't think that all of them are going to continue to survive for the next, 10 years. I just think that there's going to be consolidation in the space. Even over the next maybe 1 or 2 years, you'll see a lot of these startups either get acquired or maybe one or two of them are going to break out and become the leader in the specific vertical that they're targeting. But it's just not sustainable for the ecosystem to have sort of all of this, because ultimately the people who are making the decisions around which vendor to pick, they don't want to have to pay, 500 different companies and integrate products from 500 different companies. And that's just a huge pain in the ass. So I think that we will see consolidation. And that is where I think Render also comes in, where we try to give you a lot of these features out of the box so you don't have to worry about, all right, well, which vendor do I go get this from next?
So how can technical leaders evaluate the choices between all these cloud platforms? For example, how do you calculate the total cost of ownership in this space?
People often forget the cost of engineering and the engineering time that goes into maintaining infrastructure on AWS and GCP and Azure. It's very easy to look at the cost of a VM and say, oh, that's going to cost me less than what it costs on Render. But truly, for most companies, engineering costs are way higher than their infrastructure costs. And so I want to reinforce the idea and the advice of making sure that if you're deciding to go with something like Kubernetes, then you have considered the amount of time it'll take to spin up new developers on it and to have an operations team that's constantly monitoring Kubernetes. And I say that because that is what we spend a lot of time on.
Yeah. Yes.
And I think that I would want people to consider, and we see our users sort of making that calculation themselves. I'd want them to consider not just the infrastructure costs, but also the engineering costs when it comes to picking a cloud provider.
Well said. Thank you very much for your time today.
Thank you for having me.